Afternoon, guys. Once more, this is our second video on hyperbola graphs. My name is Shakespeare and Grove, as you would know. Obviously tutoring under Sampeth Mathematics. There's the guy there trying to, to be recognized facially. All right, that's fine. So let's just quickly go through this example specifically. You can see there's still a hyperbola graph, but there's something that has taken place in this hyperbola graph. This hyperbola graph has moved 2 units upwards. It has moved 2 units upwards. There's been a shift. This is called transformation. This is vertical transformation. It has gone up 2 units. Now we need to study the equation here. They gave us the equation. The equation is y equals to 3 over x plus 2. So the first thing that we need to quickly do here is identify our asymptotes. We did say that for hyperbola graphs we have 2 asymptotes. The first asymptote is going to be the vertical asymptote. You could start with the horizontal asymptote. Nothing is stopping you from doing that. Vertical asymptote. We've got the vertical asymptote, or you can just probably just write VA, vertical asymptote there. The vertical asymptote, we did say it's the x values, right? So the x value here, what is x not supposed to be there? Check that x is not supposed to be 0. That's how I always approach it. So you put 0 there, the whole thing becomes undefined. Now, the second thing is the horizontal asymptote. We did say these are the y values rather. So the horizontal asymptote is the y value. You can see from the graph, we're saying it's 0, x is 0 because there's a 0 there. Now, for the horizontal asymptote, you realize that y is going to be 2. So we've identified that. It means we can now produce the range and the domain. Simply done. This is going to be the domain. I'm going to quickly go through it. The domain, we said, is the possible values of x. So this is going to be x is the element of real numbers, but x is not supposed to be the asymptote in this case. You can see that the domain, possible values of x is the element of real numbers, but x cannot be 0. Where am I taking all of this? I'm taking it from the asymptote, because the definition of the asymptote, I was told, or we were told, that the definition of the asymptote is the fact that it's the value that the graph should not touch. For the x values, it's that 0 there, because if you plug in 0 there, you realize that that whole thing is going to be undefined. Now we need to look into the range of this graph. The range of this graph. The range, we know that y is going to be the element of real numbers. We're saying y could be anything, but it skips. So the graph is going to go up and up, and actually just when it gets to 2, you can see that it jumps 2 and goes up further up there. So we're saying y can be the element of real numbers, but it cannot be, y cannot be what? Cannot be 2. Where am I taking that from? I'm taking it from this thing over here. So that's very important to understand. The other thing that I need to mention, which I forgot to mention, is the value of k. The value of k is that value there, which is 3. It's positive. Now we need to always look at that, because it helps us identify the position of the graph. We know that this is now the first quadrant, and that's the third quadrant. Yes, it has followed what we started with. So the graph exists in the first and the third quadrant. The value of k is greater than 0. So that's how it's positioned. So this is very important to understand, that the graph is shifted up. So there's going to be a lot of shifting here, but this one is specifically for a graph that's shifting up, and it's giving us an equation that looks like that. We can see that this is a plus 2 rather. That plus 2 tells us the graph has gone up 2 units. Alright, and the asymptote is, the horizontal asymptote is y equals to 2. The vertical asymptote is x equals to 0. And this is how you produce the domain and the range. Okay. And I'm not saying this is the definition you're going to find in your textbooks for the range and the domain, but we've made it easier at Sampeth for learners to remember this thing, that the domain and the range basically, this would have to do with x values, that is the y values, but it can't be all the y values. It can, but for this graph specifically it can't, because the domain has to do with what can the graph not touch, and it can't touch 0 in this case, and the range for the y values it can't touch 2. That's basically how you approach this entire graph. So I'm hoping that you guys have understood this, and we're going to jump off to episode 3, where we're going to now find the equation of a hyperbola graph. Hopefully you guys understand this. Thank you. We'll see you in the next episode.